Welcome to another 6Win demo about boosting NFV performance. In this demonstration, we show how easily 6Win Virtual Accelerator integrates into Canonical's OpenStack environment using Juju Charms. Then we show 6Win Virtual Accelerator's dramatic and efficient improvement in throughput and latency when compared to vSwitch. To demonstrate ease of installation, our Canonical OpenStack setup comprises 5 different physical machines, a mass server, a bootstrap server, 1 OpenStack controller, and 2 compute nodes. We create the environment and the Juju controller. Thanks to the 6Win Virtual Accelerator Juju Charm, deployment is automated to easily scale 6Win Virtual Accelerator across large numbers of nodes. We wait until the Juju mass environment is ready before deploying the OpenStack environment using the 6Win Performance Bundle. Deployment progress is monitored through the Juju status command, and deployment is complete when all units' workload status is in active state. Thanks to Canonical and Juju Charms, only 4 steps are required to leverage 6Win Virtual Accelerator Performance Boost in your NFV. For this demo, we will skip the first 2 steps consisting of provisioning the 6Win online repository credentials and Virtual Accelerator license file to the Juju client machine. 6Win Virtual Accelerator Charms as well as guides are available free for download from the Juju Charms store. Credentials and license files should be provided by your 6Win support team. With OpenStack deployment done, we use Juju and the configuration file to deploy 6Win Virtual Accelerator. We configure the relations between Virtual Accelerator and the Nova Compute and Neutron vSwitch OpenStack components and use the Juju status command to monitor the deployment. 6Win Virtual Accelerator is now installed, and we use the Juju dashboard to check the installed environment and verify that the relations between Virtual Accelerator and Nova Compute and Neutron vSwitch are correctly established. After creating the VMs and before running the tests, we make a quick check of the system configuration. Thanks to 6Win Virtual Accelerator's transparency, this check relies on standard Linux commands typically used for this purpose. For example, the IP-link command can be used. eTool is also available and can be used on physical or tap interfaces to retrieve interface statistics or other information, and also for debugging. Another tool that's available is tcpdump command and can be used anytime for debugging the traffic flow. For the comparison tests, we have a test bed comprising 2 compute nodes, one with Linux OVS and one that includes 6Win Virtual Accelerator. Both nodes have the same VM, 6Win Turbo Router, to remove any bottlenecks linked to packet processing capabilities of the VM. An Ixia traffic generator transmits traffic at full line rate across the 2 10GbE links and measures throughput and latency. Grafana is used to collect statistics from the nodes. We first measure the throughput and CPU utilization of the non-accelerated compute node. Before starting the Ixia, note the top Grafana graph showing 0 throughput and the graph below showing the host CPU utilization during this idle period. We add the Ixia gauges and start the generator. We see the system under test reach its maximum throughput of 5 gigabits per second while receiving 19.7 gigabits per second of traffic. The top graph confirms the VM is transmitting 5 gigabits per second of data traffic. The bottom graph shows that Linux is using 4 cores to achieve 5 gigabits per second of traffic forwarding. Now we move to the second part of this test. The second throughput test uses the accelerated compute node leveraging 6Win Virtual Accelerator. The test is started with the same procedure as the last. We can quickly notice that the system reaches full line rate. Transmit and receive equal to 19.7 gigabits per second. To simplify, that is 20 gigabits per second of throughput. 6Win Virtual Accelerator provides a 4 times performance boost over Linux. We also see CPU utilization is reduced to 1 core and is confirmed by both the Linux graph and the FastPath core graph on the right. That is a 4 times reduction in core utilization, or 3 free cores that can be used for other purposes, increased VM density or increased throughput. The second set of tests measures the latency of the systems under test. Through the magic of video editing, we run the tests side by side, or more appropriately, top to bottom. The tests are run at 10% of line rate to prevent packet loss and skew the measurement. The average latency for Linux is 112 microseconds, whereas the average latency for 6Win Virtual Accelerator is 9 microseconds, a 12 times reduction compared to Linux. In summary, we showed the quick installation process of 6Wind Virtual Accelerator into an NFV infrastructure using the Canonical Juju Charms. We also demonstrated the performance boost with efficient hardware resource usage. Additionally, we demonstrated how 6Wind Virtual Accelerator efficiently improves throughput and latency. The results are impressive. 6Wind Virtual Accelerator throughput increases 4 times, while latency is reduced by 12 times while using only 1/4 of the cores used by Linux, increasing VM density by 4 times or more. If you are interested in testing our 6Wind Virtual Accelerator, please send email to support@6wind.com for an evaluation license. That is all, and thank you for your patience.